All right, so the past couple of days, guys, we dealt with monomials and combining like terms. We looked at the product rule, okay? Product is another word for what? Multiplication, okay? The product rule stated that we add our exponents anytime that we're multiplying monomials together, okay? Today we're going to look at powers of monomials. What's another word for powers? Exponents, okay? So we're going to be looking at some variables that have exponents. We're going to be looking at some coefficients with some variables that have exponents. And those monomials are going to be raised to another power or have an exponent with them outside of the parentheses, okay? So if you're looking right here at the example, guys, it says to raise a monomial, okay, to a power, you're going to use the power rule. And what the power rule states, guys, is that anytime you have a monomial, which is going to be for us x, and it's raised to another power, you are simply going to multiply those two exponents together. So for here, it would be represented as a times b. Okay? So it's just the dot, guys, I just use the period. I put a space so it doesn't look like it's at the bottom. Because if you just go a dot b, it looks kind of it's at the bottom. But if you put a space in between, it does not look so bad. Okay? It looks a little more centered. Okay? All right, so that's all that is, guys. Product rule, add your exponents anytime you're multiplying monomials together. But anytime that you have monomials that are raised to another power, okay, you're going to multiply those exponents together. Okay? All right, so looking here at example number 1, we have x squared, and that x squared, everything in that parentheses is raised to the power of 5. Okay? So here, that would be represented as x, multiply our exponents, that would be raised to the power of 10. Now good there? All right, looking at the second one, parentheses, m to the 7th, n to the 4th, close parentheses, all of that is raised to the power of 4. So it's not just the n to the 4th that's raised, everything inside the parentheses. So you'll have m, which is going to be raised to the power of 28. And then you'll also have n, which is going to be raised to the power of 16. All right. Quickly, let's look at number 3. Like we talked about on Monday, don't forget, guys, what is understood to be with this c? A 1. So this is going to be c raised to the power of 3. 1 times 3 is 3. And then we have d, which is going to be raised to the power of 6. Okay. Now, after looking at those with just the variables, we're going to look at some where we have coefficients added in. You guys remember, that's the number we're multiplying by, or what we sometimes call our base number. Okay? Now, so like it says, the first step, you simply raise the coefficient to that given power. Okay? After that, you simplify the variables with the power rule. Okay? So our coefficient, guys, or that base number, it is treated just like you would with a regular exponent. Okay? So if it's 2 raised to the 4th, that means you would multiply 2 times 2 times 2 times 2 again. Okay? All right, so looking here at number 4, guys, you've got 5x to the 7th. All of that in the parentheses is raised to the power of 2. So what would 5 squared be? 25. Remember that base number, the coefficient of being multiplied by itself that many times. So 5 times 5 would be 25. And x would be raised to the power of 14. We simply just use the power rule there to get our exponent. Okay? All right, looking at number 5. We got 2x squared y, all closed inside parentheses, raised to the power of 5. Okay? All right, 2 raised to the power of 5? Anybody know? All right, my suggestion would be 1, have a strategy to use. 2, you could use a calculator. But again, it's what? 32. So we have 32. X is going to be raised to the power of 10. And y to the 5th. Everybody good there? All right. Number 6. All right, we got negative 2 p to the 4th, q to the 6th. All enclosed in the parentheses, and all of that is raised to the power of 2. Now, don't forget, guys, that negative goes with that 2. So that is negative 2 being raised to the power of 2. So it's not just the 2, it's the negative 2. So that's really going to be represented by negative 2 times another what? Negative 2. Okay? So negative 2 times negative 2 would be positive 4. Okay? Be careful there. Okay? Then we have P, which is going to be raised to the power of 8. And then we're going to have Q, which is going to be raised to the power of 12. All right, look at number 7. We got a negative 4. Okay? Again, remember that negative 4, that whole negative 4 is raised to the power of 4. We got C to the 3rd and D to the 4th. Again, you guys are going to need a strategy or a tool or something to help you out with that exponent. Okay? What is negative 4 raised to the power of 4? 256. Good. C is going to be raised to the power of what? 12. And D will be raised to the power of 16. Again, guys, don't forget about your little exponent tool up there. That X squared button in the toolbar. Very beneficial. Okay? All right, number 3. All right, we got negative 3 raised to the power of 3. Don't forget, it's the negative 3, so you got to multiply by negative 3 each time. Okay? So what is negative 3 raised to the power of 3? Negative 27. Because remember, negative 3 times negative 3 gives you that positive 9. And then positive 9 times that negative 3 will make it that negative 27. Okay? And then my X will be raised to the power of 6. Y'all good there? All right, look at number 9. All right, number 9. Now, again, like we talked about, guys, just because we have a fraction, it does not change what we do. It does not change the process. Okay, so 1, have a tool, have a strategy, or you can just multiply it in your head. Okay, but no, it's still just a half times another half. Okay, and what is a half raised to the power of 3 going to be? 1 what? 1/8. Okay, so we're going to have 1/8. Okay, A is going to be raised to the power of 9. B raised to the power of 12. And C raised to the power of, oops, that's bad. Oh, no. Only my undo button's gone. All right, so back that up. 1/8. 1, there we go. 8th. Good. A. And we said to the power of 9. B. Power of 12. And C raised to the power of 15. There we go. All right, good. All right, so we're going to look at a few right here, guys. We're going to look at 10, 12, and 14. This is a combination of what we've done already. We're going to have combining like terms with monomials. We're going to have the product rule, and we're also going to have the power rule all combined into one expression here. Okay, so looking at the first one, guys, this one, what rule applies right here that I just highlighted? We have power rule because there's an exponent there, okay? But then if you're looking again right here, what I'm about to highlight, the multiplication symbol, that would be considered to be the what? Product rule. Okay? So the first thing, guys, is just like order of operations. Are you going to do exponents or are you going to do multiplication first? Exponents. Okay? So looking here, you've got x to the third, y to the third. All of that is to the power of 3. X is going to be raised to the power of 9. Y is going to be raised to the power of 9. Good. I'm going to space it out. Oop. Take that away. And multiply times. And then we just have just x, y. That's brought down, raised to the power of 2. Does everybody agree there? All right. Now, we did the power rule. Now, the product rule states that we do what with our exponents? What? Just add them. Okay? Do they have to be alike to add our exponents with the product rule? No, they only have to be alike if we're combining like terms. Okay? So here, we will have x will be raised to the power of what? X will be raised. Oh my goodness, I did this again, didn't I? There we go. X will be raised to the power of 10. And y will be raised to the power of 11. We good there? All right, let's look at 12. All right, so with 12, what rule do we have here that I just highlighted? Power rule, because we got an exponent. Okay. What rule do we have here that I just highlighted? It's just what I highlighted. It's the power rule. Okay. But then if we go back and all of this, after we do the power rules for both of those, we would have the what? What sign is in the middle? It'd be multiplication, so that's the product rule. Okay? All right, so looking here, we've got a negative 2ab squared. All of that's raised to the power of 2. Negative 2 squared is going to be what? Positive 4. Okay, a will be raised to the power of 2. B will be raised to the power of 4. Okay, then we've got 3 raised to the power of 2 is going to be 9. Remember, it's not 3 times 2, it's 3 times 3. A will be raised to the power of 4. And B will be raised to the power of 2. Okay? All right, coming right down below that. Now it's just the product rule. What does the product rule tell me about the coefficients, the 4 and the 9? We simply just multiply those together. So we got 36. A to the 6th. Good. B to the 6th. Everybody good there? All right, let's quickly look at 14. All right, we've got power rule. We also have over here, what does it mean when you got two parentheses next to each other? Multiply, that's going to be the product rule. And then what sign do we have right here in the middle? What sign? Addition sign. So that potentially means if we have like terms, we can combine them. Okay? All right, so look real quick right here. We've got 2 raised to the power of 3 is going to be 2 raised to the power of 3, 8. A is going to be raised to the power of 6. Good. And then we have our addition sign, our plus sign. Okay. Product rule here, we're going to have 3 times the 1 is 3. A is going to be raised to the power of what? Product rule means we do what with them? Add them. 6. Okay? So then we just have 3a to the 6. Now, what we have here, 8a to the 6 plus 3a to the 6 are those like terms. So we simply add those two together and get 11a to the 6. Remember, combining like terms, exponents and variables stay the same.